Hello guys, welcome to my YouTube channel. So from today onwards we'll start this trees playlist where we'll discuss the trees, the types of trees, the different traversals on trees and questions related to trees, easy, medium, hard. And basically this is the agenda for the playlist. Let's understand what trees are. In this video probably we'll discuss mainly about what trees are and what are the component of the trees and how we can implement them in Python like that. Okay, so yeah. So basically what is a tree? Tree is nothing but it's a data structure, right? So it's a data structure and it's obviously used to store some data. Okay, now this thing on the left side, this is a tree, right? This particular thing, this is a tree. Okay, now what can you observe here? You can see there are few units here. This. What are these? What are these units? These are nothing but these are nodes. So basically a tree is comprised of different number of nodes and they are connected in a fashion. We'll discuss what that fashion is, but first let's understand what nodes are. Okay, so basically node is something which is having three properties. Okay, it's used to store data obviously, and how we are storing the data in the node. So basically it has three properties. First is it will have a value, second is it will have a left child, and third is it will have a right child. Now, what do you mean by value? So, I think value is very evident. I don't need to explain it. For example, if we pick up this particular node, this is having a value of 3. So, similarly, any node is having a value, right? So, that value is referring to that particular thing that it's storing. Okay, the number, whatever. Okay, so that is what the value corresponds to. Now, what is a child? Let's understand that. Okay, so basically let's take this particular node. Okay, let's say we are taking this node. Now we can see it is directly connected to this node and this node, right? Now it is connected directly to these three nodes. Now one thing that you can see is these two nodes 4 and 5, these are directly connected to 2. And let's suppose we are having some levels. Let's say this is the first level, let's say this is the second level, and let's suppose this is the third level. Alright, so we can see that 4 and 5 are directly connected to 2 and it is having one level higher than the node that is 2, right? So we can say that this 2 4 or 2 5 is holding a parent child relationship. Okay, so basically, so similarly this will be true for all of the nodes. In this particular scenario, 1 is the parent for 2, 2 is the child for 1, 4 and 5 are the children of 2, 2 is the parent of 4 and 5, similarly like that, right? So now one more thing that I need to tell you is this particular node from where your tree starts, that is known as the root node. So this particular node is nothing but root node. Okay, now in this particular example we are discussing binary tree. Okay, what is a binary tree? So different type of trees are there, right? But in this particular example I have took a binary tree. A binary tree is nothing but it is a tree which is having a property. What is that property? The property says that each node can either have either no children at all, one child, or two children at most. Okay, so this is what the binary tree is like. Okay, so let's suppose we take node 2, we can say it is having two children, right? We take node 3, it is having one child. Now if we take node 4 5 or 6, we can see there are no child originating from these nodes. Okay, so we can say that these are the leaf nodes. Okay, what are leaf nodes? Leaf nodes are those nodes which are not having any child. Okay, so this is leaf node. Okay, and once again, this and this are leaf node, this is a root node. I have discussed about the parent and child. Okay, and now let's understand what is left and right. Obviously it's very evident again, right? If this is 2, this child that is present here, it is it is the left child, and this child that is present on the right, that's the right child. So every node will have these three properties, and if we comprise different number of nodes in a tree in this fashion, such that they have like either 0, 1 or 2 children, right? We can say that we have successfully created a binary tree. Okay, let's try to implement that. How can we implement that? We'll have to have a class, right? Let's suppose we have a class named as tree node. Okay, let's have our constructor here. Now whatever value we are passing, we are assigning the val to that. Okay, now initially the left child and the right child would be none. Obviously you have to create the connections, right? But initially when you're creating the node, it will be none, right? Both left and right child. So this is how your tree node class will be created, right? Let's try to create some nodes, and let's try to build a tree. Okay, let's suppose we created a root node, okay, which is having the value 1. Okay, actually we'll try to implement this one only, this tree only. This is like 1 2 3 4 5 6. Okay, all right. So we can see, right, that it is having, so on the left of the root we saw another node that is holding the value 2, right? This is the root node. This is the node that is present at the left child, as the left child for the node, right? So we give that connection, root dot left is equal to tree node of 2. Okay, root dot right is equal to tree node of 3, right? This root's right child is 3, right? So yeah, we did that. Now 4 5 and 6, right? Now 4 is root's left child, right? So we can say root dot left is equal to tree node 4. Again 5 is root's left's right child, so root dot left dot right is equal to tree node of 5. Similarly with 6, it's root's right child's right child, right? So that will be tree node of 6. So this is how you will create this particular tree. So I think you guys might have understood what trees are, how we implemented that in Python, and I mean binary tree for this example probably. Okay, and yeah, let's meet in the another video and we'll discuss more on trees. So yeah, all the best.